Okay, perfect. Okay, hello and welcome, dear participants, to our session today entitled Urban Vision of Water and Guidelines for the Promotion and Implementation of Green and Blue Infrastructure for Urban Communities. You're enjoying a course offered thanks to the support of the GEF CReW Plus project, whose purpose is to provide knowledge and a space for the co creation of water and sanitation solutions in the wider Caribbean region. The GEF CReW Plus is a collaborative project funded by the Global Environment Facility, co-implemented by the Inter-America Development Bank and the United Nations Environment Programme in 18 countries in the wider Caribbean region. GEF CReW Plus is being executed on behalf of the IDB by the German Agency for International Cooperation and the Organization of American States, and on behalf of the United Nations Environment Programme by the Secretariat of the Cartagena Convention. The GEF CReW Plus project offers innovative, nature-based solutions to mitigate the effects of untreated wastewater on the environment and public health. The Central American Institute of Public Administration, ICAP, is the institution that specializes in the education and training of human resource at the local, national, and regional level. So it's a pleasure for us to be the institution in charge of facilitating this learning space. The institution was created in 1954 within the United Nations with the support of the Economic Commission for Latin America and the Caribbean within the General Secretariat of the Central American Integration System. My name is Maria Paula Rojas, and I'm the project assistant. I will be the person who will accompany the teacher this morning. And before we begin, this session will be recorded and uploaded to the ICAP Virtual Campus website. If you do not wish to be recorded, I kindly request you that you indicate this via the meeting chat. The training provided in the framework of this academic program will be divided into modules. This session belongs to Module 4, in which we will address an introduction of green and blue economic concepts, circular economy techniques, and nature-based examples. In addition, we remind you that open active participation during the synchronous sessions and the completion of the evaluation activities hosted in the ICAP Virtual Campus, you can opt for a certificate of achievement issued by ICAP with regional recognition. All set? Now I will introduce the facilitator of the module. The facilitator with us today is Dr. Jochen Hack. Is a full professor of digital environment planning and leader of the interdisciplinary research group SEE-URBAN-WATER at the University of Hanover, Germany. From 2018 to 2022, he was a full professor of ecological engineering at the Institute for Applied Geoscience at the Technical University of Darmstadt in Germany. He is an expert in environmental modeling of nature-based solutions and the study of the green infrastructure and ecosystem services. Jochen holds a PhD in environmental engineering on integrated water resources management and a diploma in civil engineering from the Technical University of Darmstadt, one of the Germany's leading technical university. He has more than 15 years of experience working in Latin America and the Caribbean through research and teaching stays of several weeks in Costa Rica, Nicaragua, Ecuador, and Brazil. I will now give the floor to Jochen to begin the module 4.
Yes, thank you very much for this kind introduction and welcome to all of you to this module. I'm really happy to talk about green infrastructure today. One first request to you, you have seen this slide and it's also the chat. I would like to make this this presentation more interactive. So I will use the Slido application. You can scan the QR code with your smartphone or go to the web browser and enter slido.com. using this code. I can show it in a second here on my browser window. So when you open slido.com, you will see a blue field where you can enter this code. Now, once you enter the code, you get to the page. We will use this for some Q&A. If you have questions, you can type them. And I also have provided some polls. As you know already a little bit about my person, I would also like a little bit more about yours. So this is what I would like to start with, to show here the first poll. So when you're in this Slido application or in the browser at the Slido web page, you are now able to vote. This is the first poll related to the country where you are participating from, not necessarily where you belong to, where you're coming from, but actually where you're now at, where you're working, I suppose. So just to get an idea of who's here with us today. That looks good, seems to work. You can see here that we have 6 people that have voted already in this poll. So let's wait a little bit. I see we have around 19 people, well, including the staff and instructor. But I would like to reach, let's say 12, maybe up to 15 votes. That would be great to get a bit more representative result. Great, Belize and Trinidad and Tobago are leading. Guyana, seems that we have several people from those countries. Yeah, 10 people by now. This is also an exercise, as the following polls will be more related also to green infrastructure, your knowledge on green infrastructure, and some thoughts on how you think green infrastructure could be used in your working context. 11, great. Again, you can see here the QR code on the slide. It's the same. You will always use this same web page code. You don't need to create an email account. You don't need to register. You don't need to put your name. You can do this anonymously. So it's very easy access to use this application. Okay, 11. At least one more. Please try to get to the Slido app and to give your vote. Otherwise, I have to vote as well. It's not indicating Germany here. I have to vote for another country. Oh, I'm missing countries maybe in the list. Maybe there are some people that are not able to vote. Okay, well that's fine for now. Thank you for votation. So you have a kind of an idea what the people are coming from, the different countries. So just another second question regarding your main area of work. A bit your professional background now. You're more working, well, this is the main area, so the principal work, working area: tourism, finance, environment, housing, urban planning, energy. Is it culture, agriculture, forestry, health, fishery, or maybe another area? Okay. Okay, water is also here the wastewater sector. So we include wastewater in the water sector. Okay. Well, at least the same. 11 persons have voted. Okay, that's a nice picture. Mostly your main area of work is in the water sector, followed by the environment, tourism, and also finance and others. Maybe you can put in the chat what does others mean. If there's another sector Ah, yes, there are people, more votes coming in. Great, 15. Oh, now I'm happy. Now I'm happy. 15 votes is great. Yes, and now we have a tie, environment and water, two sectors in front. Great. That's a bit what I expected, but nice to see that we also have here attendees from other sectors like the tourism or finance sector. Great. Okay. Another poll, and now it's a bit more difficult. Now you have the option to type. I would like to know from you, what do you associate with the term green infrastructure? Like kind of a brainstorming. There's no right or wrong answer. Just what comes to your mind when you hear green infrastructure? What is maybe a term, a word that you relate to it, another concept that you relate to it. So please type what comes to your mind when you hear green infrastructure. This will create now a word cloud. If several people write the same word, then the word itself becomes bigger. This to indicate that several people are mentioning the same word, like sustainability has been mentioned by several. So now you can type several options. So it's not limited to only one entry. You can do several, submit several ideas. Yeah, management, sustainable buildings, utilities, and cities. Interesting, green infrastructure. Well, the topic of this module, it's related to urban areas, to cities, but maybe you also think of green infrastructure in more remote, rural areas. Yeah, resilience, biophilic design, great. Eco-friendly, management, climate change. Adaptation. Okay. Yeah, several of you related to the climate change challenges as mitigation, adaptation approach. Integrated, yeah, tree, soil. Oh, now we have several new entries. Erosion, planting, mangroves. Yes, good. Interesting thoughts here. Prevent, treating. Of course, the intention is to somehow do better with green infrastructure, somehow to confront challenges, climate change challenges, biodiversity challenges. Um, Not yet mentioned are maybe the direct social benefits. It's implicitly in some of your mentioned, but of course, green infrastructure is, and that's what we are going to talk about, is for the well-being of society. Good. Thank you. 14 of you have participated. I think this is fair enough to get a bit an idea of what comes to your mind when you hear green infrastructure. Okay, now the next slide, this is the Q&A. Right, there's an example. I'm from Costa Rica. This is now a means to collect questions. So you have the opportunity during the entire duration of this module, of this presentation, to post questions. So, for example, this is mine. Now, it's just a test. So you can give thumbs up like this to the entries, to the questions. So they can be given priority somehow. And also, well, if I think it has been answered, so it can be withdrawn. So I will withdraw this one. So that's the way how this Q&A section functions. After a while, I will show this slide again with all the questions that have come up. So you have the chance, so you can review questions and talk about some of the questions. So yes, so this is the view then, and you can see you can always change between polls and Q&A. Well, now at the moment, no poll is active anymore, but the Q&A, and once the poll is active, you will see it here. That's the same in the smartphone application, just for you to know. Okay, great. So let's jump into the topic. So this is the table of contents. So what we will cover today is organized in 4 large parts. So the first part is about green infrastructures in general in urban areas. So an introduction to the concept, what it means in urban areas. The second part is about an experimental implementation of green infrastructure prototypes in Costa Rica. This is from a research project that I'm leading, the SEE-URBAN-WATER project. So I will share with you some experiments about the process of how to implement green infrastructure and what are the challenges and what are means to achieve a successful implementation of green infrastructure. The third part covers a more general topic of promotion implementation of green infrastructure in Latin America and the Caribbean, which is showing a bit broader an approach of what are the different dimensions that need some kind of a transformative change to achieve an actual promotional implementation of green infrastructure. So how can this be successfully be promoted, this concept? And the last part is about the development and application of guidelines for the promotion of and implementation of green infrastructures. Okay, so let's start with the first topic and the introduction to green infrastructures in urban areas. So my background is from civil engineering, in specifically water management and hydrology. So my entry point towards the concept of green infrastructure is coming from the water sector. So you can enter the concept of green infrastructures, of course, from different starting points. Could be from biodiversity or maybe climate adaptation. But this is now in regarding the water cycle. So yeah, I'm showing you the natural water balance with different arrows. So the size of the arrow indicates more or less the or the share of the water flow. So in a natural environment, you have the precipitation as an input, and usually on average, the evapotranspiration is the largest share. So most of the precipitation will turn into evapotranspiration, transpiration by plants or evaporation from water surfaces. And to a smaller share, you will have, in the second place, the infiltration. And actually, the smallest share is usually the runoff component, when you have intact natural vegetation. Now, when urbanization takes place, this water balance changes drastically. Assuming that precipitation will stay the same, we import a lot of water for water supply to cities, for domestic use, for industrial use. And through the urbanization or the transformation of the landscape surface sealing, we will change all other water flows as well. So there will be usually less plants in urban areas, so we have a reduced transpiration, often also less water bodies, so we have also reduced evaporation. The soil sealing leads to reduced infiltration, but at the same time, due to all these changes, we will have a production or generation of wastewater. So we have wastewater discharge. In many cases, still it's untreated wastewater that enters the environment, or we need to treat it to protect the environment. And we also produce large volumes runoff, of surface runoff. When it rains and the surface is sealed, there's no no way to infiltrate for the water. It's not retained by plants or water bodies. So we have a problem of large runoff volumes, which often leads to inundation, flooding problems. Now, the intention of green infrastructure, and this is now the water flow of a water-sensitive city when green infrastructure is implemented, is to come back to the water flows at a magnitude of more or less a natural water balance. Of course, we still have artificial water flows, like we still need to import water to cities for different uses. But the idea is to introduce more vegetation, of course, to improve infiltration, to increase evapotranspiration again, but also to look for techniques to reuse wastewater and to reuse stormwater so that the runoff and wastewater discharge can be reduced. Interestingly, these changes, so the increase of evapotranspiration, is also solving problems, for example, like the climate regulation in cities. So with an increased evapotranspiration, we also have a cooling effect for the city that has been lost due to the loss of vegetation. And also biodiversity goals can be introduced. So the water sensitive city has benefits for the water cycle, but it also has additional benefits. They can be ecological benefits related to biodiversity, to safeguard remaining existing ecosystems or those that are impacted by urbanization. But it can also have several additional social benefits. And that's what green infrastructure is actually about. It's not just about improving the water cycle, it's also intended to improve ecological functions and to add social benefits. So thinking of a water sensitive city that has green infrastructure is meant, well, as shown in the slide before, to reproduce somehow a natural hydrological cycle, to mitigate the problems of urban runoff in quantity and also the quality problems of urban runoff, to minimize the impact of urban development, but also to maximize the landscape integration and to maximize social and environmental values. So these are the added values of green infrastructure when we design cities in a more water sensitive way. Now, green infrastructure can take place, or the implementation of green infrastructure can take place at different scales. It can start at a building scale, or the building and the surroundings of the building, like is shown here in this image. And we can think of elements like a green roof that is retaining precipitation, so it retains rainwater. It allows vegetation to grow, and it can regulate the temperature of the environment surrounding the building, but also of the building itself. So it can be of benefit to the residents of the building and can bear also biodiversity benefits. There's also a possibility to have urban gardening, could be even on the roof, in a green roof, but often also surroundings of buildings or spaces considered during the planning phase can serve for urban gardening and to produce food and support the food supply of residents. Also other spaces in the surrounding of buildings, when you think of areas for transit of people or just to recreate, can be designed in environmental friendly way as green spaces and not necessarily need to be paved always. So this can also have social and ecological benefits. Within the building and the building surroundings, water that is used can also be reused and recycled. Specifically, the gray water is the most easiest used water that to recycle. So the gray water refers to the water that comes from the kitchen sinks, from showers, from the washing machine, and that can be treated with low technology requirements and can be reused inside the building or for watering an urban garden or recreational green spaces. And also thinking of the building and where it's located here, you can see a building that is next to a river, can be and this is the idea of a landscape integration, can be integrated in the dynamics of a natural landscape. If there's the river, and for example, flooding is an issue, there's also a means, and this may be more advanced and sophisticated, but it's also possible to integrate or adapt buildings or spaces around the building to be flooded at certain times without causing damage. So by design, allow dynamics of natural environments in the surroundings. So here in this slide, there are shown several examples for building scale or surroundings of buildings, elements of green infrastructure that are examples. There's also a web page that I want to show, which I was looking for in English web page. And there's one interesting web page of the United States Environmental Protection Agency, EPA. So you can see they have a very good documentation of green infrastructure, of what is green infrastructure. You can see here several illustrations of examples of green infrastructure. So that's a quite useful web page that you can find when you look for green infrastructure EPA. You will definitely find it. So it has a lot of information, also cost-benefit analysis and guidelines. So it's for the United States context, but I believe it's quite useful also for your context. So this are some examples. Now here again comes a short question for you regarding what kind of examples of green infrastructure do you know of or in your area of work? So do you have experiences with green infrastructure? What kind of green infrastructures have been implemented in your working context that you know of? So it's not about that you have heard of green roofs exist, but really what examples have been implemented in your area of work that you know of. So again, you can type in your answers. My jungle, that's interesting. Maybe that needs to be explained. What is my jungle? Parks, national parks, yes. I have not, and on purpose, I did not give a definition yet for green infrastructure. So you're not influenced by any provided definition, but you already mentioned some important elements when you mention national parks or the jungle. That means I assume green spaces, green elements, which are not in the first place maybe developed or have not been developed as a green infrastructure, but which form part of a green infrastructure. So important elements. Grass pavers, yes. Rainwater harvesting. Yeah. So that's those are similar. The rainfall reservoirs, rainwater harvesting, stormwater retention ponds. So maybe different sizes, household level or building level rainwater harvesting. Stormwater retention are often collecting a larger area of surface runoff. Vertical gardens, yeah, like living walls, green walls. Permeable pavers, yes.
Hello, good morning.
Yes.
Yep, yes. Sorry, let me turn off the speaker.
Okay, was there something that you wanted to mention? You're also allowed to speak up. You're not that many people that it will end up in a mess, but if you're free to talk as well. Okay, rooftop gardens, like an urban farming, I understand. Great. Good. Yes, thank you. That's quite a lot. I'm really encouraged to see so many green infrastructures that have that you know from your working context. That's great. Okay, let's continue. Now here is now a definition. That's one definition. There are several definitions. This is now, I would say, more a European definition. I've shown the webpage of the EPA in the United States. In the United States, green infrastructure is very much related to stormwater management issues. But that's maybe the most important connection green infrastructure. In Europe, in other parts of the world, green infrastructure is often thought beyond the stormwater management. So here's a definition from the Ecologic Institute that's based in Germany that defines green infrastructure as a network of natural and semi-natural areas, features and green spaces in rural and urban, terrestrial, freshwater, coastal and marine areas. So first, it is a network. That's very important. Then it is composed of natural and more or less natural. So natural, semi-natural areas, green spaces, and both in urban and rural areas, and of any kind of ecosystem, be it terrestrial, freshwater, coastal, marine areas, all can form part of a green infrastructure. But very important is the network character, and that is not only about natural or original areas, but also includes these areas designed by humans. And those this network on all the elements that it includes should together enhance ecosystem health and resilience. So the idea is that you create something that is based on nature, let's say a nature-based solution that is kind of an ecosystem that has to function and needs health and needs to be resilient. Then it should also contribute to biodiversity conservation. So that's again in the same line of ecosystem health and resilience. The basis is biodiversity, of course, for resilience and ecosystem health. And the third point is it should also benefit human populations through the maintenance and enhancement of ecosystem services. So ecosystem services are different services provided from nature to humans. Could be food supply, water supply, could be regulation of the climate, regulation of water quality, regulation of the water cycle, like flood control, for example, but also cultural services like for recreation or any even religious purposes, meaning of nature, for example. So this is the idea, the broadest idea of green infrastructure. That, of course, is difficult in an urban context to achieve, because in an urban context we heavily modify the landscape and we don't really can talk much about ecosystem health and resilience and biodiversity protection as not the main objectives of building a city. But still, green infrastructure has become an important concept in urban context as well. And it is, and this is the second part also of the definition, more about how it is achieved, or how should it be achieved, and that's through strengthening a strategic and coordinated approach. So a strategic and coordinated initiative that focuses on the maintaining, restoring, improving, connecting existing areas and features, as well as creating new areas and features. So we should think of the green infrastructure in urban areas really as the network. So the same idea of networked areas, natural, semi-natural areas, what is already there. Hopefully in a city, in a given city, we have green spaces, and maybe we have some more natural ones, like an urban forest, or even in coastal area mangroves. And we also have built green spaces like parks or sidewalk green, street greenery. All these elements should be thought of in a strategic and coordinated manner. to try to really create this network, because in the network function, it provides much more and many more services than just thinking of an individual tree or a single park. That's the idea. So green infrastructure means this strategic coordinated approach, at least at a city level, maybe even beyond city and surroundings. Could be sort of also the food supply for a city from neighboring areas, could also be an approach to green infrastructure. So the concept is very much about this strategic network thinking. And it's about what we have, maintain, restore, improve what we have as green spaces of different kinds, but also create new areas and new features to improve this network and to really connect areas as well. Connecting areas is important on the one hand for biodiversity conservation, to create larger habitats, to create corridors for migration, to create nesting space or provide material, food material. So that's important for biodiversity. But the connecting element is also important for a human-friendly environment. So walkable city, for example, or cyclable city. So you create connectivity with green spaces that people can walk and reduce the traffic, vehicular traffic, for example. So this is also a connectivity. That's more the social connectivity that can also or should also be improved when thinking of green infrastructure. So you see it enters on the one hand into the ecology, the biodiversity conservation, but it also enters into the mobility transformation of a city probably. So I've shown the image of the green infrastructure at the building scale. Now this is an image that shows green infrastructure thought more at the city, or at least a city sector scale. So you see the different elements of green roofs on some buildings. You see some roadside greenery. You see the river with riparian areas and some green features. Now, thinking of a larger area allows to think of more functions. So not just functions related to the building itself, the use of water, for example, or use of green space surrounding the building, on top of the building, or at the sides of the building. Here now it's about really thinking at a larger scale. And one important element is to deal with the runoff, to think of how to connect areas, because usually a green roof will not control all the runoff. And also we have a lot of paved areas. So we need to deal with the topic of to capture runoff wherever it's possible. So to reduce the pressure on the infrastructure, the drainage infrastructure, and also reduce the flood risk associated. So this is a task, a strategic task, not just thinking of the engineered structure of conveying stormwater, but also think of green infrastructure elements that can help to do this job. This can also be done by creating something like water parks, so water bodies in the city that storing water during the rainy season, and that the water can be used in the dry season. So to water plants, to be used for different purposes. Maybe an often integrated example is to use these water parks also to provide water for fire protection, for example, in cities, which is often required, and try to create them as water parks at best with social and ecological functions. So with an ecologically sound design and integrated in social recreational spaces. The elements like rivers or lakes, water spaces in the city, larger natural areas can also be adapted in the city. So the city can adapt to these spaces. So to, like at the building scale, have a more dynamic use of the space, so that flooding of areas can be allowed. At low flow times, areas become areas for recreation, and at high flow times, they're flooded and provide storage space for a river runoff. Also, some areas may be designed, as shown for the example of the building, to be flooded. So that also creates additional storage space to confront flooding issues. and to reuse. So that requires the design of this area to these specific times when they are flooded. Also, the green grid is an element that connects green spaces, that is really thought of connectivity to provide ways for wildlife and also for people, like the walkability that I mentioned in cities. And also you can think of routes, because the water, stormwater control is an issue, areas that are where water is routed when it comes to flooding, so there's excess water, but the areas are designed for this purpose as well. Yeah, urban flood ponds is somewhat similar to these adaptable edges. So interesting, when cities have problems with flooding, and often it is really a problem with how to deal with excess stormwater. There's no way to retain it or to infiltrate it in very densely constructed areas. Then often the only way is to create spaces that are flooded. So there in dry time, there's maybe a playground or even a parking lot, and when it rains a lot, then it is flooded. It needs, of course, to have all the safety protection, but that is what actually is happening when there's no other way to deal with it, to have areas that are flooded on purpose. Okay, so this is now the the idea of green infrastructure more at a city or landscape level. Now I have here a few key characteristics of green infrastructure that may have popped up already. One is the importance of a critical mass. This comes from the network character. So there needs to be a critical mass to really think or achieve the functioning of a green infrastructure or a certain degree of connectivity. So it means we are not talking about a tree. A tree is not a green infrastructure, but it has to have some kind of connectivity. That's one element, one key characteristic. The other one is the benefits to people. So this is already in the definition. So it has to contribute to the delivery of ecosystem services. And when we, as said in the definition, so we are dealing with an ecological function and also a social function. So then by definition, the key characteristic of green infrastructure is multifunctionality. And this is more true even in urban areas. So it has to serve several functions, maybe at the time for people, but at least for people and nature, it has to serve a purpose. So that's then about dealing with infrastructure that is not single objective, but multi-objective, thinking of nature conservation, public recreation, or other social functions at the time. And another interesting characteristic, because it is an idea of a network and strategically planned, coordinated infrastructure citywide, that it tends to increase green solutions, green areas in an urban area. It needs to be, well, it needs to have a substitutability with gray infrastructure. So it should be able to replace functions of man-made or gray infrastructure. For example, to deal to have more nature-based solutions for flood defense or for water treatment, for pollution control, or as recreational infrastructure. So that is also a key characteristic to think of how solutions can be more nature-based in the end. The coordinated interventions was mentioned in the definition as well. So yeah, that's part of the strategic approach. Now, related to the multifunctionality, here are some functional areas, let's say. So one domain, I believe this has become clear, is the water quality, water supply. So functioning to purify water, to regulate water. Another functional domain is the climate change adaptation and mitigation. So enhancing natural flood management, coastal protection, for example, microclimate regulation through green roofs, the biodiversity conservation, an important aspect, and soil protection as well. And finally, of course, the human health, quality of life, and well-being. So functioning as recreational areas or improving functions that are important for human health in cities. Now here on the next slide is another question to you. This is now, what is your opinion from the place where you're at? What natural, semi-natural, or built elements could be part of an urban green infrastructure? What could you imagine when thinking of your surroundings, maybe the place where you're at now? If you have a window, you can look out the window and think of what you see, what could be natural, semi-natural, built elements that could form part of this urban green infrastructure network. There may be singular pieces, parts of it, but thinking of the idea to plan, to coordinate, and maybe additional spaces, green spaces are added, and then they become together a network. So here again, to collect some ideas, what is out there in the city that can be or could be a part of a green infrastructure. Okay, you have some ideas. Yeah, different natural elements, constructed elements like constructed wetlands, gardens. You mentioned streams. Yes, maybe sidewalks. Probably you've heard of linear parks. So this expresses already the corridor function. So streams, for example, are very important corridor elements for biodiversity very much. They can also fulfill a very good social connectivity function. So you have singular elements, but also we have some connectors, like corridor elements that are important. And you mentioned that's true, like more built elements, like a permeable pavement. Permeable pavement, there's often a discussion how nature-based is this solution. If it's not very green, it could be without any vegetation, so really just a porous pavement. It might not be in situ an ecological solution, but through the functioning in providing means for infiltration, so facilitating infiltration, it can have its ecological function in an implicit manner. So it is reducing surface runoff, it is increasing groundwater recharge. So it's not a direct, but it has an indirect impact. So it's fair enough to think also of these solutions. That's usually done when there's an idea of urban green infrastructure that it includes also such built solutions or rainwater harvesting. So a rainwater barrel has nothing green, but it has an ecological function, of course, with its impact that it has. But it's important to also think of, let's say, actually green, so involving vegetation solutions, like building elements, the green walls, vertical gardens, green roofs, streetway greeneries. All these elements are very important, of course, because they provide the direct biodiversity benefits by providing pollination services, for example, that supports biodiversity, be a habitat or food source. Yes. Yeah, nearby forests. I'm here at the moment, I'm at the city of Darmstadt in Germany, and the city is surrounded all sides by a forest. And it's a really important resource, and it's an important part of the green infrastructure of the city, as it's used for recreation a lot, and it is a refuge for all the wildlife. I wish we had mangroves here. Nothing like that. Okay, great. 13 people. Good job. Okay, let's continue. I have to look at the time. Okay, we have a little bit more than an hour. We come to the second part. The second part is about the experimental implementation of green infrastructure prototypes. So I hope this is of particular interest to you. So here I'm going to talk about the SEE-URBAN-WATER research project. You can see here the web link. If you want to look at the web page, it's in English, although it has a German ending. But you can explore the web page if you want later on to read more about the project. It's a 5-year project that has started in 2018. It's funded by the German Federal Ministry of Education and Research. And the research group is now based in Hanover, Germany. My working place is that, where I'm a professor at the university. And the research is carried out in Costa Rica. So it sounds strange at the first point, but the whole research team is made of people from Latin America, so researchers from Latin America that are gaining their PhD at the German university, but doing all the research over 5 years in Costa Rica, where we do field trips. So at the moment, 2/3 of the team are in Costa Rica, actually, doing field work. And this is how the project is working. And you can see here in the picture, there are several people involved, students, PhD students, myself, and different people interested in working in Latin American context. The project principal objective that we follow is the idea of green infrastructure for the city and particularly for the rivers. So we are having here a focus on water issues related to green infrastructure. And the idea is to co-design and implement green infrastructure prototypes in a study area to try to scientifically evaluate, optimize the performance in different dimensions, ecological, also the political dimension of how to improve implementation, promotion of these elements, also in socioeconomic terms, so cost-benefit analysis, with the aim of establishing best practices for the design, implementation, and later on, of course, the replication of this, what is being done in a study area. So that then the next level, so the second spatial scale is the urban watershed scale, where we evaluate the existing green infrastructure and the services that it provides, and also develop recommendations based on what we have learned in the study area for the improvement and propose a strategy, a coordinated strategy for the promotion of green infrastructure in the medium and long term. So basically at the watershed level, we do a lot of modeling. We try to extrapolate the ideas or the experience gained from field work in the study area and to bring it to a strategic level, let's say. So I want to show in the few slides, I will try to show you a little bit how we proceeded with this project. So how did we do this? So we started, when we started in Costa Rica, we had identified one urban watershed in the metropolitan area of Costa Rica, so in the region of the capital of Costa Rica, that has several issues with flooding, problem of contamination of water bodies. And we started with local partners, the local university, a process to identify the study area where we would implement the prototypes of green infrastructure. So the first step was, we call a participatory selection of the study area. So the watershed that we identified is shared by 6 municipalities. And this was one of the initial meetings that we had with representatives of the municipality, which were introduced to the idea of green infrastructure. We exchanged idea about what is green infrastructure in the Costa Rican context and what is this about. We explained the objectives of the project and that we would implement with funding from Germany green infrastructure elements as prototypes in an experimental manner, and that we wanted to investigate neighborhood regarding the maybe the hurdles of implementation of green infrastructure and see how it performs. So we asked the municipalities to provide proposals from their administrative areas that are within the watershed, with ideas of what kind of green infrastructure could be experimentally implemented. So we provided a form for them to fill out. So all municipalities had the same form. They presented a satellite image indicating the area with opportunity to draw in it, and then several questions regarding the idea they had, what kind of green infrastructure elements they would like to implement, how the neighborhood looks like, what are the main problems, maybe how is the social structure, social organization of the neighborhood, what are there is other initiatives, for example, and what is the green infrastructure that is existing in this place. So we received several proposals for different areas with specific ideas, proposals for in a study area and experimental sites to implement green infrastructure. This was really thought as an entry point. It was not the idea that they would design and finalize a design. It was really to think and to brainstorm where they could imagine that green infrastructure could work and could contribute to social and ecological benefits of a specific area within their administration. So this, you see the watershed. That's more or less a small watershed, only 23 square kilometers. Here is, let's say, the capital, San Jose, and here's the airport of San Jose. So when you come from the airport, you are crossing this area. Here's the central highway crossing the urban watershed that goes to the city of San Jose. So that's more or less 10 kilometers, the city center or 15 kilometers city center of San Jose, the capital of Costa Rica, far away from this study area. So as a result, we identified here this study area, this area of neighborhood. Here's an image of it, where we started to work, to do intensive field work, to investigate and to prepare the implementation of prototypes. This process was very important because it assured us the support of the municipalities with the proposals. We knew more or less about their motivations, their intentions. The probability of their support was much increased by this proposal from their side. And that was really important to us. For the 5-year project, we had to make sure that we have the people, the administrations on our side, because they decide in the end what happens. And so this was really important. But also we noticed what are the main issues that they see in their areas. So is it river degradation? Is it the flooding? Is it environmental contamination? So they also, these proposals revealed the main issues, the main problems that the municipality sees in their administrative areas. So here we only were able to work in one area doing this project to do this detailed work, but the whole watershed was, let's say, the secondary spatial scale to analyze the green infrastructure of the whole watershed, and also the replication of measures and the impact of the replication of the measures for the whole area. So that was the first step. In the second step, then we started, and this is an image of the area that was selected as a study area. You see this right next to the river. And we started a co-design process of green infrastructure prototype development. So this also, although the municipality had some idea in mind of what kind of green infrastructure could be implemented in that area, we wanted to involve the residents, the people that work and live in this area in the design process. So we started really for almost 2 years an intensive exchange with different stakeholders in the area to come up with the kind of green infrastructure that should be prototyped, and also the placement of where it should be implemented. And beyond the implementation of the prototypes, also what else could be done to improve, to strengthen existing green infrastructure. For example, the river is an important corridor, important element. Also is red because there is flooding problems in this area. So that was the intention. And this co-design had four steps. So the first step, and I will explain then in the next slides, was the site analysis and the co-design process as initial step. The second one was to establish design criteria and develop placement strategies in the area. The first one was to develop spatial typologies, some units, specific units that are repeated in the area that define different typologies, so different suitabilities for certain green infrastructure elements. And the fourth step was then the spatial suitability assessment for nature-based solutions, so green infrastructure elements. So I will go through these steps with some examples. So the first step, the site analysis and the co-design process. This is just an extract of the whole step. So as examples, the process of active involvement of different stakeholders. So we had different activities. We tried the first step, let's say the easiest step, was to enter an exchange with the organized parts of the society. So there's a community organization, let's say, that is made up of representatives of the residents without political colors, let's say. That was the first step where we could enter and connect. Then we organized street markets, we organized workshops where we invited people. We did interviews with residents. We also had exhibitions of which had more an educational purpose, and also to showcase different ecosystem green infrastructure prototypes. And we also worked with the social sciences group of a university with students in the area doing social research. So very different means to end up with a high degree of interaction with the residents and to get an idea to in the end find what type of green infrastructures are suitable, appropriate regarding the demand of the residents and the stakeholders, what are possible suitable locations and dimensions, so geometries, and what kind of design aspects revealed from this. So in this process, here an example of the interviews. For example, we did in an intensive surveying in the area where we just had a short questionnaire of 5 questions that related to the perceptions of the people regarding green spaces in the area, increasing green spaces and reducing the space for cars, and options to treat grey water in front of houses by plant-based solutions. And also the last question was about the willingness to pay. So I just showed 2 questions and let's say the answers to the 2 questions. So one question, and you see the map of the study area. So all properties, like the little boxes, the properties, and those that were surveyed are either green or red. So those residents who said yes, who were interviewed and said yes to more green areas, are shown in green, and those who said no are shown in red. Of course, a large majority is in favor of more green areas. Also, some said no, there's enough green space, we don't need any more. So that was one step. Another one was then a more challenging question. If the people would be in favor to reduce the car space, so the area that is designated for parking or trafficking cars, and in order to increase the green areas. And here you see a different picture. So 2/3 of the people were against this. And this was for us a clear signal that at this point, of course, this should not or has not to stay like this, but for our project time, the 5 years, we will probably not be able to turn the streets into green spaces. So that was a clear picture. Although there were some people who were in favor of more green spaces and would wish to reduce the car space, but not the majority. So these are two examples, and with all the other questions together, we defined a certain metric, let's say, that was used to identify the location where most people are in favor of such a green infrastructure solution, where we could most probably implement a green infrastructure prototype because many people are in favor of such a solution. So that was more in this part of the study area where we could identify specific sites for the implementation of green infrastructure prototypes. The second step in the co-design process was then to design criteria and to develop placement strategies. So this is related to the multifunctionality of green infrastructure. We considered 3 dimensions here: the hydrological, ecological, and social dimension, with different criteria that were used. So how this a progress towards a certain functional dimension could be considered. So you see the criteria: runoff control, biodiversity enhancement, and the social was more accessibility to green spaces. Then we defined strategies, how this could be achieved, these criteria, and also defined some indicators. You don't need to read all this, just to have an idea how we proceeded in the development of placements, design and placement strategies. So this is also to measure the performance in the end of the green infrastructure. That's not directly related to the green infrastructure prototypes, because there are just a few elements where we could evaluate, assess the implementation process, the design process, but at the site scale, and the performance of an element. This is related to a network thinking of green infrastructure, because we also wanted to show beyond the infrastructure prototypes what a green infrastructure network could look like. So define a suitable location design for the entire area beyond the sites of a prototype implementation. Okay, enough talk from my side. Another question for you. So this is now a different form. The question is now, what is the functionality that you consider most important? So you can vote, can make a list. So you can check one option as the highest priority, then you check the second one, the third, fourth, and the fifth. So you have to make 5 choices and then click on send. And then we get like the order of priority in functions from your side. You can move them around once you have selected when you want to change your mind, but do this before you click send. Okay, yes, that is working. It's a kind of a different polling activity. It takes a little bit of time to think about priorities. I think I will also vote. Let me see what I consider more important. Oh, it's difficult. I would also rank several at first priority. But we have to choose. We have to make a choice. That's life. Okay. I voted. Yeah, climate change, adaptation, and mitigation. It's now in front. Maybe some functionality is like something cross-cutting, like transversal issue that by choosing it as priority, it will also fulfill other functions. Of course, they are highly interrelated, these functions. Climate change, adaptation, and mitigation comes with human well-being and health. So, but not necessarily. It doesn't mean that any human health function, well-being function is also a climate change, adaptation, or mitigation function. Yes, great, 14 people. That looks good. That in front is the climate change, but closely followed by water quality and supply. I hope I haven't influenced you too much because I'm talking so much about water. Great, that's good. That tells me that you have not fallen asleep, that you are still active. Great, good voting. We have to continue, but that's a nice picture to see what you consider as most important. And that was with the Spanish module, the same case on Tuesday. I did the same polling. Soil protection was the last point. Now, of course, it is probably not the main priority in urban areas. Okay. Now the third step, that was a short break. So we came from the multifunctionality criteria as for and indicators for multifunctionality and some placement strategies. Now this is related, this is the spatial typology. So here for an example for a road type, by assessing the traffic load and also the geometry, so the width of the street, of the sidewalk and the green space, we develop typologies of streets. So type 1, type 3, type 2, type 3 of streets. And according to these typologies, we developed options for different green infrastructure. So here you see a highly trafficked street where there's only the existing green space possible to use because an invasion of the street space would be conflicted with the traffic, and also the sidewalk is very narrow already. So the existing space had to be used at best. Now, a road type 2 is a residential dead end road, which allows to give up space for green space or to have permeable pavement, for example. So here are other options possible. And in the neighborhood, we had both road types, even other road types, and also different types of open spaces, public open space. So we built typologies for the different kinds of spaces that exist to get more standardized options for green infrastructure for different sites, and not to have always individual solutions. The fourth step, the last one, was then based on the steps before the spatial suitability assessment. You see the different options of green infrastructure that were investigated and that were then, let's say, mapped based on the established methodology, based on the typology of space, and then the potential for the area for implementation of these elements was evaluated. So here comes again another question, another task for you. So this is again the same type of poll as before, as the last one. Again, here it's about the feasibility of different green infrastructure elements. So what do you think is the most feasible one? Now again, think of your personal context that you have in mind and do again a prioritization of the different green infrastructure elements. Now there are several ones. Yes, great. Then the first voting coming. again, you have to select all in an order that you want them around and then send. Ah, no, it's 3. I'm sorry. This one you have 3 priorities, so you don't have to select all, but you have to select 3, the most feasible ones for you. Then click on send. You will have your vote. So now I'm exploiting you a bit for doing my research here with you to see. It's not representative, I'm afraid, this survey, but at least it gives me some input, some ideas from your specialized group. Yeah, I was expecting that permeable pavement will be the most feasible. Of course, it has the lowest conflict with other uses. You're actually not really changing the use of an area. You're just adding a function. The same is true with the infiltration trench. The stormwater tree can mean that you need additional space probably, as well as the bioretention area could mean that you need to give up space, parking lot or street space to have a new element. But let's say permeable pavement infiltration trenches are the least invasive elements. Yeah, and you see constructive wetlands and retention ponds are maybe more conflicting, more space demanding could be. Give you a little moment more. Okay. Good. Fair enough. Thank you. I hope this is also interesting to you to see what comes out. Okay. Regarding this last step, the suitability assessment, I want to show you one example. Considering the bioretention area as one green infrastructure element, here is shown a possible design solution for this bioretention area. So you have a vegetated area. Here's an inlet where the stormwater runoff from the street can enter and can be stored. This area usually has also a drainage for excess water, so it gets not flooded and has no overflow, but an underground drainage. It could drain to an existing stormwater drainage system, sewer system, or it just ends to a different nearby water body or something. So here's defined for this element the intention. The intention was to design it, and this is shown in this picture, as an element that is integrated in the road system that also has a traffic regulating function by narrowing the street width and reduce the velocity of cars. So here we have the road types that are suitable. This is the typology of roads, and we have the placement criteria. This is based on technical standards for these elements because they are implemented in parts of the world already, and technical manuals exist that define principal design aspects. So based on this criteria catalog, the suitable or the potential placement locations were mapped. So this is again the study area. Here's the river. This is like the highest part. You see the elevation, so the contour lines. So this is like the flow direction, let's see. And you see numbers. So for the bioretention areas, a total of 28 potential placement sites were identified. This 21, for example, here you see the satellite image would be this bioretention area here. So this was done for all the different elements for this area. And based on this, even in the green infrastructure performance was evaluated based on the indicators. I don't have the time to show it all. I put a link to a publication where this can be retrieved, where we published the results of this analysis. This just to showcase what was the suitability assessment about. Also, to gain even more space. So this was related, let's say, to maintain the actual use of the space. So to not close the street or change the characteristic of the street. So here, for example, this is a road where there's not very much traffic. So it was possible to implement, let's say there's enough or the traffic is that low that you can actually have an obstacle in this road, and cars just would have to wait because it's just one lane when there's a car coming, and just after the car is passed can go the next one. But here we also sort of ways how we could gain more space. So this is thinking about a mobility transformation, to thinking of how the traffic can be rerouted, let's say, because in reality all streets are both way, so the cars are heading in both directions, but it's possible to reduce or at certain points define one-way directions. So one-way streets like here, or this could even be one way when you say this is to leave this area, here you can enter. This could also be one way when you enter here and you leave here. So there are options to change the way the traffic is routed in the area. This will allow to gain a lot of space. That's a really important aspect. We used tactical urbanism. That's a means where you just block a lane of a street for a certain while temporarily to see how the traffic adapts and how you can also try out alternative uses of this space. We use this to simulate how the space would be, or how the users of the space would adapt to a new condition. That's an experiment that can be done quite easily for just a short amount of time, and you see how people react and how traffic flows, for example. And well, also street design can completely change. So the dead-end roads, which are those here in green, could have a different design. Permeable pavement and introducing more green space, green areas would be possible for these areas once you design them as a new road type that actually in the legislation does not exist yet in Costa Rica, but it could be, we call it like a playground street, that we call it in Germany, areas where people have more privileges than cars. Cars have to go very slow. There's few parking space. In the area is more a playground for people and not for cars. So that's also another way to gain more space. Then here an example, this is from, again, the same publication where we assess the spatial suitability of the performance. So here see the indicators and the achievement of by the full urban green infrastructure implementation. So how much would be the share of the increase in green spaces in total, the length of roadside greenery that would be activated, how much more above ground vegetation would be created, new habitats. That's for the ecological dimension, actually. But you see, we also assessed the runoff reduction, for example, the runoff control by modeling areas. This red area is one drainage area, so all this area drains here to this point. So we modeled this and also could quantify the surface runoff reduction, so the stormwater runoff control by this green infrastructure network. Okay, so that's that was all the way to the definition of locations and types of prototypes, and then we actually implemented the prototype. And here, just to explain a little bit more what we understand as a prototype, it's a pilot scale measure to investigate the impact of green infrastructure on urban water management in a built environment. So on purpose, we worked in an area that was already developed. It was not a new design, but we call it retrofitting of a built environment. And we considered different design principles that resulted from this co-design process. One was the construction in existing public space. Then do not affect the current use of space. So not reducing street space or walking on the sideway, and the intention to add a new function to the space to improve landscape environment, so the landscape environmental aspect and the water quality reaching the river. So here are the prototypes that we constructed in the beginning of 2020, right before the pandemic hit the world or all places. So we achieved to construct these prototypes before we had to stop traveling. So one was, we did it at different scales. That was another approach. One was at the household level. So a household solution to treat the gray water that is actually by all households discharged to the street and that drains to the river without treatment, to treat this water and to have a vegetated space in front of the house, which also has aesthetic function. And this is a solution in collaboration with the house owner. So it's a responsibility of the house owner, this solution. We tried out different solutions, different actor constellations, also to have different instruments that could be incentivized by different political means, different political instruments. So this is one where the house owner has the responsibility and cares about it. We also did a similar solution for at the block level, so street block level, where we implemented the solution under the responsibility of the municipality, where the house owners had not to care about it, let's say, just had to review their inlet structures and had kind of to control screens where sediments or solid materials were collected before the water was discharged. But the infrastructure itself was under responsibility of the municipality. And then the third scale was then in downstream area. This is next to the river, where rainwater, grey water treatment was built in a solution that is more kind of like a constructed wetland type, which was of recreational value as integrated in a park, and also of greater ecological value. So these were the three prototypes that were developed that we are still monitoring. So because of the pandemic, we could not advance as we wanted to, but now we are producing the last results to see how the performance of these prototypes is actually. Now the last step, and this is what we are also doing at the same time, is the upscaling, develop a regional planning for upscaling scenarios. So considering all that we have learned, all the experience and knowledge from the study area, how can this be extrapolated to the entire watershed scale? So this is based on the criteria, placement strategies, the procedures during the spatial suitability assessment, and also based on the experiences with the implementation of co-designed prototypes, we could identify different sites in the watershed for replication of the different measures, those that were built as prototypes, but also others that were just assessed in the suitability assessment. And that resulted then in a watershed scale strategy and assessment. So here I want to show just one example. So here this based on remote sensing satellite images, we assessed the existing green infrastructure, so all green spaces that exist, the distribution, accessibility, ecological value of the green spaces, and then we looked for, based on these placement strategies and types of green infrastructure, we developed recommendations for additional green infrastructure elements that could improve connectivity, for example, could improve the distribution of green spaces in ecological and social function. This is just for an area. So actually here is the study area. This is the river. So it's just a small part of the entire watershed. It's much larger. But for example, in front of the study area here, you see an industrial area with large flat roofs, which could be used as or could be greened. Here are parking lots that could be flooded, used as flood storage area. And you see existing green areas, and here are green elements with green outlines, which could be additional new green spaces or improved green spaces for social and ecological improvements of the area. So that was also done. This is one example. We did it for the entire watershed as a plan to improve green infrastructure at the watershed level. Okay, now let's have a look at the time. Okay, I'm good. I'm good with the time. So there are two parts left, but those parts are a little bit shorter. Now the following is about progress in promotion implementation of green infrastructure in Latin America and the Caribbean. So we, together with colleagues from other Latin American countries, we were a group of someone from Mexico, someone from Ecuador, Colombia, Brazil, Chile, Dominican Republic. I think that was all. It was a total of 8 countries, Latin American countries, with experts on green infrastructure. And we evaluated the progress at different levels. And we developed a kind of a framework of different, well, the state of the art, of course, we documented, but also the needs and for a transformation, let's say. What are the means that are needed for promotion and implementation of green infrastructure? So we, in our understanding of green infrastructure, that it's a multifunctional, multi-scale concept, it requires for successful implementation some transformative processes. So in different dimension, things need to be changed, and we defined 5 important dimensions for transformation, which I listed here. The one is the enabling environment. Second is the institutional level. Third is management and instruments for management. Fourth is the implementation and operation of green infrastructures themselves. So, and also number 5, monitoring and evaluation of green infrastructure performance. So 1 and 2, let's say, are more the framework, the general framework. 3 is going into the operation of green infrastructure and implementation. And 4 and 5 is actually the experiences of implementation. So we actually need to implement to learn, to see how green infrastructure performs. It really fulfills the multiple function that are desired. So it requires also monitoring and evaluation. So I will show the different advances of these dimensions now in the following slides. So as examples, that could be advances. So for the dimension of the enabling environment, the enabling environment is composed of the policies. So policies that promote the implementation of green infrastructure, which could be specific regulations for the use of alternative technologies in public works. It could be a regulation to promote widespread adaptation of green infrastructure. An example is mandating that new buildings need to include green roofs, or new developments need to include functional green space that is part of a larger green infrastructure. Those are policies. Others are inclusion of rainwater harvesting. So this is all on the side of the legislation, the policy, the politics side. Another enabling element that is important is the financing. So here, different financing can result in the promotion of green infrastructure. For example, it could be disincentivized soil sealing by charging taxes for impervious areas per parcel. So the property owner has to pay for a certain soil sealing share is exceeded. Or the other way around, green infrastructure could be incentivized by subsidies for rainwater harvesting or green roofs. So these are elements that are considered enabling environments, so that really provide a good environment for green infrastructure adaptation. The institutional dimension is then related to the institutions themselves. They can be defined in policies, in laws. They define capacities. So capacity building is necessary, strengthening of capacities. We see that with our conventional gray infrastructure, we have a high degree of specialization in single or monofunctional infrastructures. Now, if we think of green infrastructure, maybe a hydraulic engineer will need ecological knowledge or social knowledge on recreational aspects of infrastructure, which is often not the case. It's not given. So we need a capacity building, capacity strengthening to have experts that are able to think green infrastructure and to also promote it. Then institutions that are responsible to regulate, to enforce green infrastructure are needed. Institutions that coordinate and facilitate green infrastructure development are needed. And this is the institutional side. So some examples, what could be advances in these areas. The dimension of management and instruments is the inclusion of green infrastructure in different action management plans and climate change adaptation mitigation plans, participation plans, so even in water management plans could be included, so that it becomes a means in the day-to-day work and strategic development. Now, regarding the implementation and operation, this is the assurance of a certain performance of the green infrastructure. So on the one hand, the engineering system itself, if the functionality works, so is the performance correct? Is the system resilient? Does it work to achieve the ecological functions? Is this economic? All this is regarded to the performance of the engineering system, but also the achievement of the goal of connectivity in ecological and social senses is needed to be assessed. And the social community resilience is related to what are the benefits, social benefits that are associated to green infrastructure that also are relevant, and they need to be assessed. Required for this is also often a monitoring and evaluation. So monitoring systems are needed to really assure these different performances in different degrees. Okay, so there more or less were these 5 dimensions that are considered as dimensions for transformative change to achieve advances in the promotion and implementation of green infrastructure. So now here another short activity, another poll regarding another prioritization now for you. What is the dimension of transformation that you consider most important? So the goal is to promote the implementation of green infrastructure. So what is most needed at this time now? When you think of your professional context, is it an enabling environment? Is it policies and financing that is needed? Are the institutions needed? Capacity building? Is it that we need to implement and operate green infrastructure? Do we need monitoring or management and instruments? So again, here you can now again have an order of 5, select all 5 and do a prioritization of the elements. To get some water. Okay. Yeah, and most important seems the enabling environment. So I assume that is probably also the financing that is important issue, but probably also the legislative or regulatory frameworks of the policies are needed as well. In my experience, well, often there are enough policies and often it's more the funding and the willingness to do, so the political will that is missing. During my PhD, I studied different water laws in Latin American countries. And at that time, wonderful water laws had been in place, but just on paper. So they had the most beautiful rules, installation of institutions, capacity building, management instruments. All that was included, but there was no funding at all. So it took time, even if there was a water ministry defined in the water law, maybe it took 10 years until the law has passed, until the ministry was established, because there was no funding before. So, and then there's maybe a little ministry with just a handful of people working for it. So then you cannot do develop management plans for all watersheds of a country. So that's a problem that I know from enabling environment. That's not necessarily the policies, but the financing is a critical aspect. Okay, 15 people have voted. Great. Enabling environment, institutional. Second place, implementation operation. Okay, good. Let's continue. This is now the last part. We have more or less a little bit more than 10 minutes. I think that is enough that it will take. So this is something, the development of guidelines for the promotion and implementation of green infrastructure is an ongoing work in the context of the SEE-URBAN-WATER project. So it is one of the outputs of the project as well. A compendium of guidelines that are based on the one hand on experiences during the project. So different activities, different procedures that showed to be successful in the context of the project were generalized and were translated into guidelines. So the generalization as kind of the lessons learned of the project is what the guidelines form in order to allow their replication, to facilitate the replication. So this compendium of guidelines is actually a web page. It's called Guías Verdes. It's in Spanish. It is in a generalized form, in forms of guidelines, the experience expressed of the project, and added to these guidelines are practical experiences. I will show it to you. This means so this was, let's say, the departure of this web page to develop a set of guidelines that resulted from the project experience. And since these were developed in the project context, we had an internal revision, but also a revision from project partners, by project partners and other collaborators, and with the target group. So those that we considered as users of these guidelines, they also help to improve what we started as guidelines, and they were also asked to complement the compendium with additional guidelines based on their experiences. So for example, another municipality in the region of San Jose, Costa Rica, had experience with the development of green roofs, implementation of green roofs, and they developed with our assistance, or they are still developing, actually it's ongoing, this project still, guidelines. So we provide the support to write guidelines based on experiences, to standardize experiences, and to add them to a web page. So the entire process started last year with the elaboration as kind of a reflection process of the research project, SEE-URBAN-WATER. We had an internal review. We had in our team, we have people from different disciplines, researchers with different backgrounds. So also to find a common language, we had an internal review, and also to more or less standardize a little bit the different guidelines. Then we had the external review, the second half of last year with the target group. They also reviewed and improved our guidelines so that they are understandable. We used the workshop and also bilateral meetings to do this. And the last part is then, a participatory process. Actually, it was not finished last year. We are still doing it for the next 2-3 months, where we try to develop more guidelines with experiences from other projects beyond our research project. So and what the website that is published now has also a comment function, so people can comment still on the different guidelines so that we can continuously improve the quality of the guidelines and add more experiences. And the last step is the dissemination. So with new guidelines that are developed, we'll have several dissemination events where we'll promote the guidelines to let the people know. We're working on social media as well, so that more and more people get aware of this toolbox, and also contribute with their experiences. So the idea is that it can grow. So the guidelines in the context of our project were developed in the process that I presented today. So the selection of a real-world lab, what we call a real-world lab, is a study area in the end. So identify a study area, the co-design process of prototypes, and also the upscaling. So these different steps that we took in the project is what structured a bit our guidelines. So we identified 4 processes. One is the selection of a study area. So how to find an area where experimentally maybe or as an alternative technology, the green infrastructure can be implemented. The second process is how can the communication and involvement of stakeholders be organized. So this is part of the co-design process. The analysis of the area and data collection for assessment of suitability of sites and placement locations. Indicators are also involved. So this is all parts of what I presented as co-design process, and also the implementation of green infrastructure prototypes, what we have learned from our experiences, what has to be taken into account, how is the procedure with the municipality to actually build a green infrastructure in the end. So here, these are the different processes that I've shown. Just some examples of the guidelines that exist. Here, the identification of an area of experimentation, so selection of a site. For example, mapping of relevant stakeholders was a guideline, or workshop to involve local stakeholders of the project area as the first step with community leaders. Then other activities related to involvement and communication with stakeholders, how to organize social events for green infrastructure promotion, how to organize training workshops, or how to involve stakeholders in monitoring activities where we monitored precipitation, for example, or water levels of a river, and so on. Then the analysis of the area, how to carry out qualitative, quantitative interviews and different environmental analysis to assess different performance indicators. Yes, the implementation of the prototypes, like how to approach the design process of prototype building, the prototype construction itself, and the identification of site potential for implementation. This is how the guideline is structured. So this is standardized structure. We have a section with objectives. We have the actual guidelines, so the steps, form of instructions, 1, 2, 3. What steps are needed to be taken to achieve the objective. And in this, we have included experiences. So experiences as are exemplifying different steps of such a guideline. So the guideline itself is generalized, so it's not context specific to be able to be applied to any kind of context, but the experiences show examples of how a certain step was realized in a certain project context. Then we have a section with rules that should be taken into account when carrying out the different steps, and a section of scope and challenges. So what is actually a scope of this guideline, of one guideline? What can be achieved with this guideline? What are the limitations and challenges to the application of this guideline? So as I said, this is a web page that is growing. So we have a few, the guidelines from our project. We have now the first guidelines from other project experiences, and we are still working on more. So we are quite open for other initiatives to propose guidelines based on their experiences to include them. So our service is to organize the reduction of these guidelines and to put them on the web page. So here I want to show you the web page as well. It's in Spanish, but you have the link. Maybe you're not known to familiar with Spanish. You can use the Google Translate. So this is how it works. It's basically very reduced. You have here the guidelines, the different sections. You have a contact area. Here's a general explication of what this is all about. Here are also the different processes, so sections for guidelines. Here you can see the individual guides as well. And here some external resources as well from other projects can be seen here. Let's go to one example. Maybe here the selection of an experimental site. This is how then a guideline looks like. As I said, the standardized structure of objective, short description here, the steps. So you see different steps, and here, for example, cross links to other guidelines if necessary, or experiences. So you can see here, for example, this is the project meeting that we had with municipalities where we collected proposals, and you can read the minutes of the meeting as well, free. So you get familiar, and also here the format of where we use to do the site selection. So this was the form that the municipality filled out to propose experimental sites. So you see how we translated our project experience to in a generalized form for others to see is this helpful, and they can replicate maybe some of this. You see the results section, rules, challenges, scope, and here's the section where you can leave comments. So anyone who reads this guideline and maybe has a question or something is not clear or has an idea of what to add can do this with a comment. The comment, it will not appear immediately. It will just be sent to us, and we can review it and answer it. Also, the contact page has a form where you can include can fill out if you have a general idea for a guideline, for example. And here you see also the team that has worked on this web page. Yes, let me get back. And there's just one last activity, and this is now for you again. taking advantage that you are here with me, do you have ideas, experiences, or guidelines for green infrastructure promotion? So you can now mention some ideas that you think, I had this project experiences that would be a good idea for a guideline that someone else could replicate. So here you have the chance. This is now a free answer. Let's say you will have again kind of a word cloud as a result. Maybe you have ideas, or maybe you know of something like a guideline or instruction for any specific aspect that is related to green infrastructure promotion. I will give you a short moment to think about it. I hope you're still there because it's now 12. Let me check the attendance. Yes, you're here. I haven't checked the. Okay, good. Let's see what comes up to your mind. You are overwhelmed by information, maybe, so you just don't know what to put. I give an example. Okay, that's an idea from my side. Okay, good. Coming in some ideas. Rooftop gardens. Yeah, retrofitting of rooftops would be very nice. Hydroponic gardens. Yeah. Okay. Well, you can continue typing. I see that I forgot. To put the slide where to show the questions, but I'm looking at them now in my smartphone, and I will just go through the question that are here. There's one question. The first one was, I will read it. With respect to biodiversity conservation, can green infrastructure introduce invasive species as well? Of course, once we introduce vegetation, well, the vegetation part is the one that we can control, that we will not use invasive species, so try to use endemic species that are native to the place. But all the fauna, the animals that will be attracted can of course be also invasive species. So it's not, it is an issue, it's something that has to be kept in mind. If there is an issue already with some invasive species, then care should be taken in the design of green infrastructure elements, especially when they are providing habitat functions. I hope that's fair enough as a response. Another question, were there any public awareness campaigns done to inform on the benefits of green infrastructure in Costa Rica? From our side, yes, we had several events, let's say. We also work closely together with the GIZ, so the German Development Corporation in Costa Rica. It has also a green infrastructure greening the city project, and there were several awareness campaigns. Let's say we did campaigns for a broad audience in their study area. So where we did the street markets, for example. So trying to really have reach out to people that usually will not participate in a forum organized by a university, for example, or so that we did in the study area. But and this year we also participated in a music a cultural event in collaboration with schools also, but with our means on a lower level. I believe it could be much broader done to reach out for people who really maybe need to be reached out to, which are not already familiar in the favor of green infrastructure. So there's actually need to do that. And here's the question: what were some challenges faced when working with the municipalities in Costa Rica? Yes, there were challenges. I would say the major challenge to us was the political change after an election. So when we had suddenly to work with different people. So that was the major challenge that we had, because we established also with this selection process of the study area. It was a very close and personal contact. So let's say with local champions, we worked with local champions that were interested in that, were willing to do something to provoke a change. When they were exchanged by someone else, we all of a sudden lost this support. So that was the major challenge. More practical challenges we had with the experimental character of our treatment, greywater treatment. There was, of course, a fear that when we infiltrate or treat greywater in a soil body or with vegetation in an urban area, that it could contaminate the soil or contaminate the groundwater resources. So there was a lot of doubts, and we had really to convince the people with also continuous measurements, make sure that would not affect a groundwater, or it would not damage anything. And we also had to, all our prototypes were designed in a form that they could easily be destructed. So we always, that was the main strategy that we had. We said we will build them in a way that very easily they can be turned back the conditions before construction of the prototypes. So that was a good way to convince the municipalities to try something out, to say, okay, if it doesn't work, we will turn it back immediately. There's no problem. So I hope that helps as a response. Yeah, those are the questions that I have seen here now. We are over the time also already. I see that you have continued here to add. Great, thank you. That will stay with me. I will not delete it, so it gives me some ideas in our project. Yeah, so I would say here's the web page again, and thank you. Muchas gracias. Thank you for being with me. That's all from my side.
Thank you, Mr. Jochen. I think there is no more questions. You already answered them. So I'm gonna close the meeting now. Thank you very much. Thank you very much, Mr. Jochen, for your presentation. We have reached the end of the synchronous session of Module 4. We remind you to review the virtual campus where you will find evaluative activities, also today's presentation, as well as the a recording of the session, and bibliographic materials to deepen in the subject. Also, your opinion is really important to us, so we thank you for sharing your feedback on this module through a survey whose link will be sent at the end of the week. The information collected in this survey will allow us to develop a continuous improvement on the modules. It has been an honor for us to facilitate this space, and I would like to thank you on behalf of the German Agency for International Cooperation and ICAP for your valuable participation. So you can disconnect now. Thank you very much to all.
Thank you. Thank you very much for your active participation in the different polls as well. Very helpful. Okay.